All right. Hello, everyone. My name is Michael, and we're going to be looking at problem 29 from the sprint round of test 12503, which was the high school test release for the month of December 2024. Let's go ahead and get started. Compute the product of all positive integers x less than or equal to 42, such that x to the ninth minus 1 is a multiple of 43. Now, looking at this, and especially without a calculator, there's no way we're going to calculate the ninth powers of 42 integers, subtract 1 from all of them, and then see if they're divisible by 43, right? That's not going to be very helpful for us at all. But we're going to start by using Euler's totient function. And Euler's totient function is actually not as complicated as it sounds. It just says it's usually denoted by phi of some integer x is just the number of positive integers will be that are less than x that are relatively prime to x. So in other words, share no positive divisors with x. So since 43 is prime, it's relatively prime to all of the integers that are less than it. So that means that phi of 43 is equal to 42. Now we're going to put that on the back burner for now. We're going to look for, right, this problem wants us to find all positive integers x between 1 and 42 inclusive, such that x to the ninth minus 1 is congruent to 0 mod 43. Or in other words, x to the ninth minus 1 leaves the same remainder as 0 when divided by 43. Now this is equivalent to saying that x to the ninth has to leave a remainder of 1 when dividing by 43. And now we're going to return to the phi of 43 equals 42. We can note, right, that x to the ninth can be written as x cubed is x cubed to the third power, right? Now, if this were an algebraic equation and we were solving over the real numbers, then we could very nicely say that x cubed has to equal 1. You cannot always do that when you're working with modular arithmetic, or in other words, remainders, because remainders, like if I multiply something that has a remainder of 5 when divided by 8, and something that has a remainder of 7 when divided by 8, that doesn't give me 35 necessarily, that gives me 3, right? So there's more than one way to get to 1 in some cases, right? Just like there's more than one way to get to a remainder of 3 when dividing by 8. Here we're dividing by 43. Now, how do we know when we can simplify? We know that we can simplify when the number that we are raising to on the outside here, 3, is a positive divisor of of the modulus that we're working with here, 43, right? So we're looking for remainders modulo 43, which means that since 3 is a positive divisor of phi of 43, we can make the simplification and now say that x cubed is congruent to 1 mod 43. And this is a lot easier to solve because we're only dealing with cubes. Now, is it practical to calculate all 43 cubes? Still no. So let's see what we can do algebraically. So we know x cubed minus 1 has to be congruent to 0 mod 43. Now we can factor this using the difference of cubes, and that'll give us x minus 1 times x squared plus x plus 1 is congruent to 0 mod 43, right? Now, x squared plus x plus 1 equals 0 does not have any integer solutions, right? But what we can do instead, right, is instead of x squared plus x plus 1, we can write it as x squared minus 42x plus 216, yes. And that is still going to be congruent to 0 mod 43. Now, you might be thinking, whoa, Michael, what did you do? Did you sleep last night? And yes, I did sleep last night. I'm not insanely sleep deprived. Why can we do this? Because, as I mentioned earlier, this is not just a simple equality. This is not an algebraic equality. What we have here is a modular equivalence, which means that going from x to negative 42x, I just subtracted negative 43x. That doesn't, since we know that x is an integer, that doesn't change the remainder of the left-hand side compared to the right-hand side. Same thing here. 1 to 216. I just added 43 times 5, or 215. So that also doesn't change the remainder. So we can do this, and this is a tool that you can often use to solve modular arithmetic equations. Now, why did we do this? Because we can now factor the left-hand side as x minus 1 times x minus 6 times x minus 36 is congruent to 0 mod 43. And this gives us our solutions of x equals 1, 6, or 36. And since we were able to make the simplification earlier, right, of going to x cubed is congruent to 1 mod 43, that means that there are only going to be 3 solutions, which are 1, 6, and 36. Now we want the product of those positive integers. That's 1 times 6 times 36. 6 cubed or 216. So that means that our answer is E, other.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.